Bill Nye, the science guy, has been sparking our excitement for the vast frontier of space and its mysteries for decades. For many years, he's ignited our curiosity about the infinite expanse of deep space overhead. Today, Bill breaks the silence about the latest images from the James Webb Space Telescope, photos that offer us a rare glimpse into the universe as it existed more than 13 billion years ago. These revelations are set to transform our understanding of the cosmos and even alter our perspective on life itself. The James Webb Space Telescope is revolutionizing our knowledge of distant planets, galaxies, and more. Not only is it a groundbreaking scientific tool, but it's also celebrated as the worthy successor to the Hubble Space Telescope. So, what are these astonishing Webb images that defy our expectations and theories, and what insights does Bill have to share? Let's dive in. Years of dedication from NASA's scientists and engineers culminated in the creation of Webb, which was launched on Christmas Day 2021. Its complex deployment over the following months went off without a hitch. By late June 2022, as the telescope came online, astronomers were already uncovering thousands of new galaxies, many older and farther away than any known before, with some dating back more than 150 million years earlier than Hubble's oldest discoveries. Webb's impressive ability to capture faint light from objects like exoplanets and nascent stars allows us to analyze their compositions and trace their movements across space. Bill Nye explains that this data is already revealing the detailed atmospheric makeup of planets hundreds of light-years away, hinting at their potential to support life as we understand it. One of Hubble's most iconic images is the Pillars of Creation in the Eagle Nebula. While Hubble captured the dramatic, visible light clouds, it couldn't reveal the hidden processes of star formation within. Now, thanks to Webb's infrared imaging, we can see countless protostars, clusters of dust and gas, many times larger than our solar system, appearing as tiny red dots against the smoky backdrop of the pillars. These are stars in the making. Bill notes that although these young stars aren't yet burning hydrogen, as more material accumulates at their cores, they become denser until hydrogen fusion ignites, causing temperatures to soar by nearly 2 million degrees Celsius. In these images, different colors are used to represent the otherwise invisible infrared wavelengths. Although we might see only blue in the photograph, those areas would actually appear red in true infrared light. The red hues, for example, indicate radiation at wavelengths about 6 times longer than what our eyes can detect. Bill suggests that this image not only highlights Webb's infrared prowess but may also provide crucial insights into the birth of stars like our Sun. Since the 1990s, over 3,000 exoplanets have been confirmed orbiting distant stars, yet only about a dozen have been directly imaged because most are too remote to observe directly, usually seen only when they transit their stars. Webb is changing that narrative. In September of last year, it captured its first direct image of an exoplanet, known as CHIP 6542-6b, which was originally identified in 2017. Utilizing its coronagraphs to block the overwhelming light of the host star, along with multiple cameras and filters, Webb imaged this planet, a massive gas giant roughly 12 times the size of Jupiter and orbiting its star at a distance 100 times that between Earth and the Sun. Even galaxies that appear elusive to the naked eye, such as the Phantom Galaxy, reveal their brilliance when observed with Webb's infrared camera. While Hubble's optical view of the galaxy, also known as M74, shows its graceful spiral shape and luminous core, a recent Webb image uncovers intricate, fiber-like structures of hot, dust and gas-laden material radiating from an electrifying blue center. This new perspective illuminates star-forming regions along the spiral arms. By combining Webb's infrared data with Hubble's optical images, researchers at the European Space Agency have crafted stunning composite images. As part of the FANGS international project, which leveraged Webb, Hubble, and ground-based telescopes to capture infrared images of 19 nearby star-forming galaxies, astronomers can now pinpoint star-forming regions with greater accuracy, measure the masses and ages of star clusters, and study the tiny dust particles drifting through interstellar space. Bill also points out an intriguing feature: Webb's distinctive diffraction pattern, usually an imaging artifact, appeared in a July snapshot of a distant Wolf-Rayet star known as WR140. Yet surrounding WR140 was a series of concentric, ripple-like rings with a slightly boxy appearance, real structures, not artifacts. These peculiar rings likely result from the interaction between WR140 and its diminutive companion star, as massive Wolf-Rayet stars nearing the end of their lives eject copious amounts of hydrogen. Webb was engineered to peer into the universe's farthest reaches. In mid-December last year, researchers announced the successful observation of 4 exceptionally old galaxies, first seen by Webb 13.4 billion years ago when the universe was a mere 350 million years old, just 2% of its current age. Along with hundreds of other galaxies discovered during the JWST Advanced Deep Extragalactic Survey, JADES, their ages were determined using Webb's near-infrared spectrograph, which measures the redshift, the stretching of light due to the expanding universe. The highest redshift measured to date was 13.2, revealing galaxies that are more distant than we ever anticipated. For the first time, Webb enables us to locate such remote galaxies and confirm their extreme distances through spectroscopic analysis. In another breakthrough, Webb has focused on a planet orbiting a star in the Virgo constellation, now the subject of the most extensive extrasolar planet study to date. Named WASP-39b, this gas giant lies 700 light-years from Earth, about 8 times closer than Mercury is to the Sun. As it orbits its star, WASP-39b's atmosphere, thick with clouds of sulfur and silicates, including sulfur dioxide, boils under intense conditions. Using Webb's main camera and spectrographs, scientists detected sulfur dioxide for the first time in an exoplanet's atmosphere, shedding light on its formation history. Evidence suggests that WASP-39b likely formed much farther from its star before migrating inward, as indicated by its oxygen-rich, carbon-poor atmospheric composition. Closer to home, Saturn's moon Titan continues to captivate scientists. On Titan, lakes, rivers, and seas of liquid methane and ethane carve out its landscape, while water ice forms its rocky surface. Uniquely, Titan is the only moon in our solar system with a dense atmosphere, and its methane clouds, first spotted by Webb last November, are exclusive to this world. The telescope's atmospheric data revealed not one, but 2 methane clouds, including one hovering above Kraken Mare, Titan's largest sea. Follow-up observations from Hawaii's Keck Observatory confirmed the cloud's presence, although its shape had shifted, suggesting dynamic changes. Researchers hope to use such data to map Titan's haze and identify new atmospheric gases. What about the Southern Ring Nebula? Once considered unremarkable, a mere remnant of a dying white dwarf ejecting its outer layers, the nebula has taken on new significance. Traditional theories held that a companion star in a binary system partially obscured the dying white dwarf's light. However, Webb's breathtaking images, captured by both its near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, reveal that the white dwarf glows with a red hue, encircled by a halo of cool gas. Bill Nye speculates that a hidden third star might be responsible for this gas, while additional images show striking shell-like structures along the nebula's edges, reminiscent of those seen around WR-140. Researchers now believe that a third star, nestled between the 2 known companions, is generating these ripple-like shells by ejecting gas and dust in very specific directions. Although not originally designed for exoplanet hunting, Webb also discovered a most unusual object. WASP-11256b isn't a conventional planet at all but a brown dwarf, a body larger than a planet yet not massive enough to sustain full hydrogen fusion like a star. This brown dwarf emits a faint reddish glow and, peculiarly, harbors sand and silica clouds, an unexpected find for an object of its kind. Webb was even able to identify key elements in its atmosphere, including water, methane, carbon dioxide, and potassium. The unusual ratios of these components point to a turbulent atmosphere, where vertical mixing upsets the normal balance between gases like methane and carbon monoxide. Ultimately, as Bill Nye emphasizes, the goal for astronomers is to discover new planets and examine their atmospheres in detail. NASA released the first spectrum of an exoplanet's atmosphere, specifically for WASP-96b, as part of Webb's initial data dump. This spectrum, essentially a barcode of the wavelengths of light absorbed by the atmosphere, was obtained as Webb spectrographs observed starlight filtering through the planet's gaseous envelope. In a surprising twist, water vapor clouds and hazy skies were detected in WASP-96b's spectrum, contrary to earlier beliefs that the planet possessed clear skies. Given that water is abundant in our own solar system, it's plausible that similar processes are at work on distant worlds. Moreover, the presence of methane, often linked to biological processes on Earth, has astronomers speculating that its detection could be a sign of extraterrestrial life. These unexpected findings have prompted researchers to re-examine both Webb's and previous data. There's little doubt that the detection of water vapor in distant planetary atmospheres challenges our understanding of where life might arise. WASP-96b, a hot Jupiter orbiting its star every 3.4 days with surface temperatures exceeding 1000 degrees Celsius, serves as a prime example. Bill Nye also touches on the tantalizing possibility of discovering life on other worlds. If we detect methane in the atmosphere of a distant planet, it could indicate the presence of life, fundamentally altering our view on life's distribution across the universe. Imagine another civilization, perhaps with its own version of the James Webb Space Telescope, studying us as we search for our cosmic origins. Webb's ability to see in infrared allows it to peer through cosmic dust that obscures other telescopes like Hubble, which rely mainly on visible light. For instance, an image of